Is my mic on? Is my mic on? Oh, I'm just kidding. Hey, these things happen, but guess what? We're going to continue on with the conference and we're going to move on to our first presenter of the day. But before I do, I've got one thing to share with you. I want to make sure that you know that all of the things here in Excel events will continue to be available for 30 days. So if you want to come back in for 30 days after the conference and even see the chats as well as look at the exhibitor documents and things like that, they'll continue to be here and the videos will be here as well. And we will permanently archive these videos on CWNP TV. So remember, go to YouTube, search for CWNP TV, all one word, and subscribe there, and you'll be notified as things are posted there in the future, not only from the conference, but other things as well. All right, at this time, we're going to move on to Robert Bartz, one of our longest term CWNTs, teaching with CWNP, all of our various different certifications. And he's going to be talking to you about a very important topic related to wireless networking and wireless network professionals. So without further ado, let's bring up Robert Bartz.
Hello, my name is Robert Bartz with 802 Technology Solutions, located near Denver in the beautiful state of Colorado. In this session today, I'm going to talk to you about troubleshooting concepts for wireless networking. And for those of you that know me and may not have seen me in the past 5 months or so, I am still sporting my lockdown beard. Here's a little bit of information about me, but I just want to summarize this by saying that I've been working with the CWNP program ever since 2001. I attended the very first CWNA class it ever ran, and I have been working with it both from a technical perspective as well as teaching it over the past almost 20 years. I have also authored 3 books for CWNP on wireless networking and 1 for CompTIA for one of their certifications as well. Today, I'm going to talk to you about troubleshooting basics, understanding some of the concepts that have to do with the troubleshooting philosophy, for lack of a better word. We'll take a look at a common troubleshooting methodology that can pertain to various aspects of technology, the OSI model and wireless network, at least the OSI model, how it pertains to wireless networking. You cannot have a technical session or a technical class on networking without talking somewhat about the OSI model. We'll look at basic 802.11 connectivity. I want to show you the 802.11 authentication and association process, which is a very important process that is required every time you connect to a wireless access point and every time you transition from one access point to another. We'll take a look at some common wireless LAN problems and some common wireless LAN troubleshooting tools. Let's start with the troubleshooting basics. Common myth. Troubleshooting is easy. As in this famous quotation, relax. All right, my old man is a television repairman and he's got this ultimate set of tools. I can fix it. Anybody remember that one? Sean Penn as Jeff Spicoli in Fast Times at Ridgemont High back in 1982. What a classic. The reality is troubleshooting is not easy. It's an acquired skill. However, for some people, it may come naturally. That picture right there on the screen happens to be me back in my aerospace engineering days, back when I was a test engineer, doing circuit level design, circuit level troubleshooting and testing, as well as systems test with the test engineering lab. Back then, I had a nice full head of red bushy hair. Unfortunately, the picture's in black and white, so you really can't see that. However, for those that it doesn't come naturally to, like it did for me, I guess I'm one of the fortunate ones, there's also other ways to get this skill, through education and training. Just experience over the years in working with various technologies. And of course, the School of Hard Knocks, which is usually the hardest way to get this kind of skill set. Is troubleshooting really just troubleshooting? Well, yes and no. For example, we have electronics and electrical troubleshooting, which I guess you can consider networking and wireless networking would fit into that realm. We have mechanical type of troubleshooting, all the things that work together, gears and all the mechanics of things. And then, of course, automotive troubleshooting, which is always a challenge, at least in today's times, as that technology has changed significantly. Let's start with engine troubleshooting. What used to be one of my favorites many years ago, and still is to some extent. And I'm going to show you an example with a Bobcat skid steer loader for engine troubleshooting. This Bobcat 610 skid steer loader example is based on a true story. This happens to be my Bobcat 610 skid steer loader. So one time I was going to use my loader and I was going to move some rocks on my property. And I got the key and went to start it up. I put the key in, turned the key, no start. Just no start or crank, as a matter of fact. Just a clunk sound when the key was turned. Well, these type of engines, I mean, this is an older unit, but basically you need power from battery, you need spark, and you need fuel. Those are three main components that are required to make this engine run. Well, first thing I thought about, was there a weak battery? Because we had no start and no crank, just a clunk sound. So the first thing I did was hooked up a vehicle to it, hooked up some jumper cable and tried to jump start it. Still no crank, still no start, or still no crank, just that infamous clunk sound. Well, the next thing I thought, maybe there's loose battery cables. So when I removed the actual jumper cable, sure enough, the battery cables were loose. So I went and tightened the cables up. Well, the good news is now I had the crank, but still no start, which is unfortunate. So the next step I want to do, remember, we need power, battery, we need spark, and we need fuel. So I thought, well, I'll check for spark. Sure enough, I had good spark. Of course, I put the spark plug back in, thought, you never know. Cranks, but still no start. How about the fuel level? Check the fuel level. Fuel level was perfect. Fuel level was okay. So we know that was not low on fuel. Cranks, but no start still, obviously. Decide to check the fuel pressure on the fuel pump. No fuel pressure. That's a good indication that it's a bad fuel pump. So I went ahead and replaced the fuel pump. And sure enough, we had a start okay, a successful troubleshooting session. And that's me proudly displaying my pile of rocks I got to move with my newly starting skid steer loader. Of course, this was a few years ago, so I have shed a few pounds since this photo was taken. Now let's look at this more in an electronic perspective. Basically wireless technology, or like I said, this could pertain to actually several different types of technologies. We'll take a look at steps in a common troubleshooting methodology. First, identify the problem. Second, determine the scale of the problem. Third, look for possible causes. Fourth, isolate the problem. Fifth, resolution or escalation of the problem. Sixth, corrective action and verify the solution. Finally, document, and document, a very important step. The first step, identify the problem. Gather information by asking questions. That's the only way you're going to know where to start to target the problem at, or to zero in on the problem. So you need to ask questions and ask more questions. You need to talk to whoever is experiencing the problem to determine where you need to start looking. Never assume anything. You know what they say when you assume. Next, we want to determine the scale of the problem. I like to say, is this a global or an individual problem? A global problem means many devices, or an individual problem meaning one device. You notice I didn't say user, I said one device, just to be on the safe side. One example of a complaint is, the internet is down, I can't do anything. Really? You can't do anything because the internet's down? Oh well, I'm not going to go on that too much. A global problem usually involves many devices or groups of devices. Devices that can be related to a global problem include things like wireless access points, wireless bridges, wireless LAN controllers, wired infrastructure devices. That's one that's often overlooked, at least on the wireless side, or just not considered on the wireless side. And of course, the individual one device, not the user. The next thing is to look for possible causes. Remember that wireless LANs have a lot of moving parts. I mean, take a look at the graphic. We have wireless client devices, wireless access points, Ethernet switches, routers, wireless controllers, access to the internet for cloud-based solutions, etc. So there are a lot of moving parts when it comes to wireless network. Also keep in mind that wireless LANs use unbounded medium for communication. So unbounded meaning the air, and the communication is going to be the radio frequency technology. And I always like to say, and always have said, don't forget about the wired side. The wireless devices need to plug in somewhere, and in many cases we also use wireless services such as DHCP and DNS, etc., power over Ethernet. So many parts on the wired side are a big impact on a wireless network. The next step is to isolate the problem. Remember that wireless LANs require two-way communication between these stations on the network. We have a radio transmitter that prepares the data to be propagated across the air, and we have a radio receiver that collects the propagated signal from the air. These are known as transceivers because they can both transmit or receive. However, wireless LAN devices are half duplex communication, which means they can do both, but they cannot do both at the same time. If a transmitter is transmitting, it cannot receive. If a receiver is receiving, it cannot transmit. That is the nature of half duplex communication. Also, it's important to understand that the transmitter must hear the receiver and the receiver must hear the transmitter in order for them to effectively communicate. So, for example, a wireless client device too far away from an access point, for example, may hear the access point fine, but however, the access point may not hear the receiver well enough to perform the appropriate task it needs to do. And again, unbounded medium, I'm going to keep on saying that, unbounded medium can cause various problems with this communications. The next thing is resolution or escalation. In many cases, this is based on previous experience. You've been working with technology before, or working with wireless technology before, you've seen the technology, you come across a problem that it just clicks and looks familiar. So that's the good news. That's an easy fix. If that doesn't happen to be the case, you can always look at the support database, search support databases, and look at appropriate documentation, because chances are, well, somebody's got to be first, but chances are you're not the first person to see this problem. That being said, if it was properly documented, it would be an easy way to research that and then be able to apply that fix to the problem. You must know your limitations. That's very important. I can't tell you how many times I've been working on problems over the years. I just need 5 more minutes. I just need 5 more minutes. I just need 10 more minutes. 3 days later, it's still not working. So you really need to know your limitations. In the words of one of my favorite actors in an older movie, Magnum Force, Clint Eastwood, as he said, "A man's got to know his limitations." Okay, that's the best you're going to get from me on impersonation. Sorry about that. The next thing is to escalate as appropriate. And that's where once you hit that limitation, whether it be just yourself from how your experience is, or whether it's some sort of rule that the organization does have put in place for that time to escalate, that's what you need to do. So escalate as appropriate based on the policy or based on the specific situation. Next is corrective action and verify the solution. So now you have the potential solution, you want to test the solution to make sure it is effectively working. When you test a solution, also keep in mind of who the actual recipient is that you're going to be testing this for. For example, somebody that would be doing Microsoft Windows administration could potentially test a solution that they put in place with their administrator account, and it's going to work. Well, they have administrator privileges. So when the end user goes to try that out, it's not working for them. Well, that's because they are now using their login credentials to perform this task, and therefore they may not be able to do the problem, or they may still have the problem because it was tested under the administrator credentials, which could be different credentials. So make sure it's tested in the eyes of the end user or the user of that device. Then you want to implement the solution after it was tested to make sure it does work appropriately. And then finally verify the solution. And that's where the end user with that problem device, or the end users with those devices, will let you know whether or not the solution is working. Finally, like I said, document, document, and document. This is so important, often overlooked. And it's not the most fun job. So a lot of people just don't do it because they don't want to, because like I said, it's not the most exciting job. So, but it is a very important part, because proper documentation makes your job easier down the road and makes somebody else's job easier as well. This could be both manual or electronic methods. So we have such a wide variety of ways to perform documentation now, with all kinds of software and databases. And there's always the good old logbook if that's the best you can do. But any way of providing documentation is just great. Because like I said, this will help you and also help others. Okay, let's take a look at one of the most fun topics in networking, the OSI model. Well, we're going to look at the OSI model with regard to wireless networking, but this is a very important part of how this technology operates. Remember the OSI model? It's the basic component of communications in a computer network environment. Consists of 7 layers, from the top down: application, presentation, session, transport, network, data link, and physical. Remember the old way people remember that? All people seem to need data processing. That's from the top down. From the bottom up, please do not throw sausage pizza away. I don't know. I say please don't throw any pizza away. Each layer is made up of many protocols, and these protocols serve specific functions at these different layers in which the header information is added. Data is encapsulated at some of these layers. Again, it just depends on which layer is at as to how that encapsulation occurs. Remember, wireless LANs function at the lowest 2 layers of the OSI model. Layer 1, the physical layer, and layer 2, the data link layer. Robert's rule to remember: know the PHY, learn the MAC. Layer 1 and 2 is where it's at. I got a trademark on that. Only kidding. Now let's take a look at the OSI model as it pertains to 802.11 wireless networking. Layer 1, the lowest layer in the OSI model, is also known as the physical layer, or the PHY. It's divided into 2 sublayers: the PLCP sublayer, which is where the physical layer header is added, and the PMD sublayer. And that is what's connecting the devices together, in this case for wireless being the air, which is our medium. So this is good for bit level data streams and computer network hardware connecting devices together. Layer 2, the data link layer, but sometimes referred to as the MAC layer, even though the MAC is a sublayer. And that's mostly because if you look at the front page of the 802.11 standard, it does say the PHY and the MAC. But again, broken into 2 sublayers, the LLC being the upper part and the MAC sublayer being the lower part. The MAC sublayer is where the MAC layer header is added. So this is responsible for organizing bit level data for communications, also known as frames, and also for detecting and correcting physical layer errors. So as data moves, we're looking at this now from data moving down the OSI model perspective. As data moves down the OSI model, when it arrives at the LLC sublayer, it is known as an MSDU, which stands for MAC Service Data Unit. The abbreviation tells you what it is: a MAC Service Data Unit. A data unit that's going to be serviced by the MAC layer. That's going to move down to the MAC sublayer. When it arrives at the MAC sublayer, that's where the MAC layer header is added. At this point, it now becomes the MAC protocol data unit. It's a protocol data unit because the header has been added. Then it moves down to layer 1. Now, when it moves down to layer 1, it just basically has a name change. At the PLCP sublayer, it's now called the Physical Service Data Unit. Again, the abbreviation tells you what's going to happen. It's a data unit that's going to be serviced by the physical layer. Now the physical layer header is added, and then it becomes the Physical Protocol Data Unit. And now it's prepared or ready to go across the air. Now we're going to take a look at the basic IEEE 802.11 connectivity. I want to show you the open system authentication and association process. This is a very important process in this technology. This happens every time you connect to an access point or transition from an access point to another. This is a very important part of the technology because every time you connect or transition, this process must be performed. It's broken down into a couple of different areas. We're going to look at first the discovery phase. The discovery phase consists of passive scanning to start with. In the passive scanning phase, basically, a wireless client device, also known as a station, is listening for beacons. Beacons are management frames that basically advertise the network, and they're broadcast frames, and it depends on the manufacturer, or settings, I should say, but the most common setting is about 10 times a second. It's actually 102.4 milliseconds, which is about 10 times a second. This contains all kinds of information about the wireless access point, about the network, the SSID, the channel it's on, the data rates that are supported, the security information, etc. The next part of the discovery phase is the active scanning process. In the active scanning process, a client station or a client device will send a probe request to the access point. This is the way the client device is going to quickly identify an access point for connectivity. The probe response comes from the access point back to the client. If you're looking at these on a protocol analyzer, you would notice that the probe response frame looks almost identical to a beacon. I said almost identical. There's a little bit of information that's not within there. So the probe response frame is now a response to that probe request. According to the standard, every time an access point receives a probe request, or an access point station receives a probe request, it must respond with a probe response. Again, this is known as the discovery phase. I want to put a little note in here is that acknowledgement, 802 acknowledgement frames are not shown in this particular demonstration. So now the next step will be to do the 802.11 authentication. And these are two frames. One is from the client device to the access point. The other is back from the access point back to the client device. You notice that these are not request and response. They are just authentication frames. Even though there's really no authentication involved. It's basically the client device saying, hey, can I get on the wireless network? After you authenticate, then you associate. Now you have an association request frame from the client device to the access point, and association response frame from the access point back to the client. So this is basically verifying compatibility, or verifying the capabilities are going to match for the devices, allowing it to become part of the basic service set. The association response frame looks very similar, again, to a beacon management frame, just like a probe response frame or a beacon management frame from the access point. Once this is complete, now your 802.11 open system authenticated and associated, and that's basically all you've done at this point. You are connected, but there is no security involved whatsoever. So this is what's going to happen when you go to a wireless hotspot, for example, hotel, restaurant, airport, wherever the case may be, and you connect. Pretty much it ends here. Now, in an enterprise or other type of situation, that's where you now have security that occurs, either 802.11 pre-shared key security or enterprise security using 802.1xe, for example. So additional things would happen after this process to secure your communications. But at this point, nothing is secured. Now let's take a look at some common wireless LAN problems. And I'm going to just kind of summarize all of these under coverage and capacity problems. I mean, that's how I'm going to summarize them. And this particular example is no wireless connectivity. Again, think about all the potential moving parts that are involved with this technology and how that can relate to some of the problems. No connectivity on the client side. Other connectivity issues, or maybe IP address connectivity issues. These are all potential problems that you may see, as well as potentially security settings is another one. So no connectivity on the client side. Maybe it's a disabled radio or wireless network adapter. You'd be surprised how many times that little switch is turned off on the laptop, or the network wireless adapter for some reason got disabled in the software. You're not going to be able to get a connection with a disabled wireless network adapter. A misconfigured wireless client utility. Again, it has to be able to match and be able to get onto the actual network. Maybe a wrong SSID, for example, or something to that respect. Maybe the Microsoft Windows autoconfig, or the Microsoft Windows client side is not running or properly configured is another potential example. And then in some special cases, protective supplicants, and this is going to be on the wireless client device side, that can disable the rate of response to specific policy violations for like WIPS type of activity, for example, things like that. Other connectivity issues, again, misconfigured wireless client utility. You'd be surprised how many times that occurs. For example, I'm going to jump into security here, but let's just say you put the wrong passphrase in on your client side. Now, on the Windows network, Windows 10 is pretty forgiving now. It pretty much tells you, hey, you put the wrong passphrase in, but maybe not all operating systems. In that case, you're going to have an 802.11 connection because you did perform the 802.11 authentication and association process, but you're going to get an IP address after the security occurs if you use like pre-shared key, for example. So if you have the wrong passphrase on there, it will never complete the authentication process. Therefore, you'll never get an IP address. So you will be 802.11 connected. You just will not have an IP address because it never completed the connection because the authentication basically failed. So that is one way where you would be able to see a connection, but maybe no IP address received because of a misconfigured wireless client utility. And again, that basically falls under the incorrect wireless security settings, what I just described. And that's also going to result in potential IP issues, but there could be other IP issues as well that could be part of the problem. So maybe you did not complete the security process, so you never got an IP address, or maybe you did complete the security process, went through the four-way handshake, for example, and still don't have an IP address. So maybe the client was set to the wrong type of IP address, static versus dynamic through DHCP. A static IP address must be manually configured. That's one that is put on the device with all the proper settings, where a dynamic IP address is one that's issued through DHCP services. This is going to issue an IP address, subnet mask, default gateway, and other important IP information. Again, wireless security settings, incorrect security settings can cause various connectivity issues. I had mentioned pre-shared key earlier. For example, incorrect security settings can also cause connectivity issues. I want to say on the advanced side, I already talked about pre-shared key, but how about things like 802.1x EAP, port-based access control? For example, the infrastructure side may be set for 802.1x EAP TLS, which is going to require certificates on everything. And maybe the client side is configured for 802.1x PEEP MSChat version 2 using password and username rather than certificate, which would cause a mismatching in security configuration. So that's going to cause connectivity issues. So they must match on both the client side and the infrastructure side. Another one is intermittent connectivity, things like receive signal strength. You got to have the right signal strength and the right signal to noise ratio to get good quality type of data exchange. So test for that received signal strength, make sure it meets the requirements based on the design. And again, weak or no signal can also potentially cause intermittent connectivity, and the notorious code channel interference, which is something that can cause various problems. Basically, when two access points are on the same channel within the same RF range, client devices can hear all the RF and therefore may be obeying rules for 802.11 for one access point, even though they don't have to because they're associated to another access point, and that's going to cause code channel interference. So understanding that is very important when it comes to this technology. Wireless LAN throughput, making sure the proper throughput is there. What can cause throughput issues? Distance from the client device. How far is the client device from the actual access point? So that distance is going to put you on the fringe of a cell, for example. If, let's just say, all data rates are enabled and you're connected to the 2.4 gig band, you're connected at 1 megabit per second. That puts you on the fringe. That means you can only, once you get a connection, you can only transmit no more than 1 megabit per second. And that's going to basically cause throughput concerns. Or maybe being at that cell edge is going to also cause a hidden node issue. which we'll talk about a little bit later on. But from a throughput perspective, when you think about it, the further are you away from an access point, or the further a client device is from an access point, the less complex modulation type it can use, because the weaker the signal. Therefore, the lower the data rate, therefore, the less the throughput. It's also really important to understand there's a difference between data rate or signaling rate and throughput. The signaling rate is how much it's advertised, what it's capable of, but the throughput is actually how much is going across the air, because of various things like overhead, other transmitting stations. The list goes on as what can cause that performance to significantly drop. RF output power settings. You know, you got to be careful with this one. More power is not always a good thing. So if the output power settings are too high, that may allow those fringe users to connect if the data rates are not disabled. Therefore, that's going to cause potential issues, as well as potentially the number of devices connected to the access point or associated to the access point. Because think about it. Wireless, number one, I mentioned many times, is unbounded medium. So it's unbounded shared medium. That's important. It's also contention based, which means if you have 5 devices on an access point, they're going to contend, and only 1 device at a time can actually transmit. If you have 50 devices on an access point, they're going to contend. So the more devices you have, the more contention you have. Now that sounds like it may be a problem. Well, it can be. It depends on the situation. Light users, depending on what they do, you can have more devices associated. Heavy users such as CAD engineering or digital imaging, for example, that could also be more bandwidth intensive, therefore potentially causing problems for the number of devices associated. So think about the number of devices associated to the access point as how that could inadvertently affect the actual throughput. Now I want to talk about hidden node. I'm going to go on a limb here. I'm going to say that I personally believe, and I tell all my students, all my classes it, I personally believe that hidden node is a problem that every wireless network does have. Now, I'm not saying it's rampant. I'm just saying that I really do believe that the hidden node problem is a very good possibility on every wireless network, whether it be a home network, a small office network, or an enterprise network. The hidden node is caused because devices cannot hear each other. I'm talking about the client device or the client stations. You know, people think that the access point is in charge. Well, it is to a degree, but as part of the distributed coordination function process in 802.11, client devices need to be able to hear each other in order to communicate on the wireless LAN. So if they can't hear each other, when they contend, they don't realize that somebody else is transmitting, then they transmit at the same time. You have a collision. A collision results in a retransmission. Retransmissions in wireless are bad because retransmissions take airtime, and airtime is valuable, very valuable in wireless LAN. So a couple of potential hidden node problems. The first one is hidden node obstruction. This is where you have maybe a solid obstruction between devices, such as a wall. They cannot hear each other because of this obstruction. So they listen to the air, they contend, they win contention, they don't realize the other one contention, they send the frames, boom, you have a collision or retransmission. Again, this is not good because that's going to impact the performance of the wireless LAN. Another one potential is hidden node signal strength. So now you have 2 stations that are associated with the same AP. They can both hear the access point, but they cannot hear each other. Let's look at a very simple possible situation here. You have a home where they install a wireless router. The ISP installs a wireless router in the basement, for example. And you have a couple of stations in the basement area and on the first floor, and they can all hear each other fine, but then maybe you have a device on the second story on the other side of the house, and it can hear the access point, but because of the obstructions, the different floors and walls, etc., they cannot hear each other. So there you have a perfect example of a hidden node, and it's not necessarily, could be also based on the fact there's obstructions, but it's probably in that case more related to the actual fact that they just can't hear each other. Or they're within the same area, a larger area, and they're spread so far apart they cannot hear each other. Another one I like to call hidden node technology, and that's where we have the signaling methods. For example, in the 2.4 gig band, we have the original 802.11 and 802.11b technologies, which are DSSS and HRDSS, direct sequence spread spectrum, and high rate direct sequence spread spectrum. And you have 802.11g devices or N devices, which use OFDM, orthogonal frequency division multiplexing. That's like speaking two different languages. So therefore, when they listen to the air, they can hear each other, but to them it's just RF. They don't understand the actual what they hear. So because of that reason, again, they're both going to transmit because they do not realize that the other device has transmitted because they don't understand the information they heard, and that causes a collision. Again, retransmission, which is bad. Collisions are bad in Wi-Fi, and so are retransmissions. That's going to impact, again, the performance of the network. Now, there is in the 2.4 gig band protection mechanisms like extended rate physical protection mode does try to alleviate this issue. But again, just be aware, if that was not the case, then you would have this potential issue. Now let's take a look at some wireless LAN troubleshooting tools, some good tools to think about for both layer 1 and layer 2, the physical and the data link layer. We're going to start with layer 1, physical layer, also known as the PHY, as we discussed. And we're going to look at Wi-Fi centric spectrum analyzers. I say Wi-Fi centric because they're pretty much designed and geared to work with 802.11 wireless LAN technology. And here's some good examples. The MetaGeek Channelizer, a great tool by a company called MetaGeek. NetAlley Spectrum XT, which we use as a spectrum analyzer, also part of their site survey design tools. Ekahau Sidekick, again, used with the Ekahau design software, but also is a spectrum analyzer. And another one, RF Explorer, which is a handheld portable RF spectrum analyzer. Again, these are just a few. There are other ones that are out there as well. Then we have the instrumentation devices. Now, these are typically more geared toward just RF. So they're more expensive, or they can be more expensive. Instrumentation devices from companies like Agilent, Fluke, Tektronix, Rohde & Schwarz. Now, from the Wi-Fi side, looking at the 802.11 technology, you can usually get these to cover less of the actual frequency band, and that makes it a little more affordable. But these can be higher in price because of the functionality. And keep in mind that these spectrum analyzers, handheld type of portable instrumentation devices, there's a lot of knobs, lights, buttons, and switches, so you really have to understand how to use it, as well as being able to use it for what you're trying to use from a troubleshooting perspective. More on the physical layer, layer 1 troubleshooting tools. I like to put site survey tools in. Now, site survey software is typically used for design of your network, placement of access point, looking for capacity, to help design the network. But think about it. These are, if you have one of these tools, in addition to design, these are great troubleshooting tools. Because now let's just say if some user is complaining about the wireless network, how well it's performing. It's not performing well in their area. You can now take your site survey software, or the device with the site survey software over there, and just kind of perform a quick survey of the area, a validation survey basically, or an assessment survey is a better way of saying it. Look for the RF, see what's there. Maybe something has changed since the wireless network was deployed. Maybe they added some obstructions, put some walls in, or some furnishings, or inventory, or something like that. So not only for design, these are great tools for using for troubleshooting as well. And some of the common ones that are out there: NetAlley Survey Pro, Ekahau Site Survey, Tamosoft Tamograph, and IBWave also has great tools. And I also like to put wireless scanners under this, which is just basically, these can be both layer 1 and layer 2 when you think about it, but mostly on the layer 1 side. MetaGeek Insider, Wi-Fi Explorer, which is Mac only, and another newer one from Windows, Wi-Fi. Again, these are just a few. So just take a quick search on the internet to see something that may work for your best needs. Now, layer 2 troubleshooting tools is basically the layer 2, or the MAC sublayer, as we talked about earlier. Protocol packet analyzers, Wireshark, a great tool that's free. Now keep on with Wireshark, you're going to have some limitations if you cannot get a monitor mode driver, for example, in Microsoft Windows. So protocol analyzers require what's called a monitor mode driver to put it in passive mode. So you have to have the right driver, which is typically provided by the manufacturer. Now, if you work with Linux or other operators other than Windows, that could be a little bit less challenging. But you do think about what you need to have in order for this tool to work. So Wireshark, a great product that's basically just free. Live Action OmniPeak is another one. NetAlley Wi-Fi Analyzer, Tamosoft ComView for Wi-Fi, and Metageek IPA, which is great for visualizing the network. And we have some throughput test tools, and I'm going to list just a couple of free ones, and free is always good. iPerf, which is a command line based tool, and JPerf is the Java graphical version of iPerf. They both basically work the same. One is just graphical. Great tools that are free. Another one is Tamosoft Throughput Tester, available from Tamosoft. Again, it's a free tool. You have a server and a client side, and you can basically get a session going to test your throughput. So great tools that are free. There are many other ones out there that you can pay for, and there might be a few other free ones as well. But these are the most common ones that I am familiar with and use and see. With that in mind, I want to thank you for listening. It was my pleasure. I hope you learned something new about this technology. Like I said, I started back teaching this stuff in early 2002 after I attended that first class in 2001, the first CWNA class that ever ran back in 2001. And it's a great technology. I've been doing technical training actually for going on 30 years now, 27 years. I've been doing technical training and the Wi-Fi stuff for nearly 20. But it's such fun technology. It's great to see the evolution. When I first started teaching this stuff, we had 802.11, 802.11b, which was rarely used, WEP, and that was it. Look at how far we've come in these years with this amazing technology. I always like to say that I believe that wireless was an extension to the network. Now I like to say wireless is the network. So here's my contact information. I'm a CWNE and a CWNT. Like I said, I've been doing this for quite a long time. My email address, my website, my Twitter handle. We are actually an authorized learning center, premier authorized learning center for CWNP. So we offer all the courses for you to take, either virtual, live online, or in person, on site, custom, private, whatever the case may be. And we are a virtual sponsor. So feel free to reach out. If you have any questions I can help out with, let me know. Thank you again, and enjoy the rest of the conference, and have a great day.
Okay, we're here with Robert Bartz live. And Robert, how are you doing out there in Colorado?
I'm doing just fine, Tom. How about yourself?
I'm doing good. Doing good. Well, good to have you with us here. And there has been a lot of discussion in the chat about something about a beard.
I need to pull it to prove that it is real. I heard a comment yesterday. Is it real or is it fake? It's real.
Yeah. So this is what happens right when we have to stay at home for a while.
That's it. 4 months, 5 months, I guess it's been.
Yeah. And that's quite impressive. I couldn't grow that in 5 months. Well, we have some questions as well. And some of the questions are related to hidden node. And so the questions about things being on walls and possible hidden node issues related to that. And then there are questions about just hidden node in general and what might be happening there. So let's talk about hidden node for just a little bit.
Okay, yeah, that seems to be a pretty hot topic there because it's so possible that it could happen. So about the predictive design, predictive design, in my opinion, is as good as the information you put in. I mean, if you have a floor plan, what is a floor plan? It's lines on a piece of paper. So you need to have the proper attenuation levels, and all that information has to be accurate because you're basically modeling. You're not seeing other RF that's out there. So a good predictive design will be a good predictive design, but the hidden node problem can occur after the design is done for various reasons. Addition to clients, maybe the environment has changed. Keep in mind that hidden node is caused by the fact that stations, in this case client stations, or actually any station, cannot hear each other. Through the distributed coordination function process. Stations must be able to hear each other in order to win contention, in order to send a single frame of data. So a design is great, a good design, good predictive model design is great, but things change. So there is always that possibility. And even the same thing with an access point being mounted on the wall or the ceiling. I mean, if the design justifies it being mounted on the wall, that's one thing. That doesn't mean it's not going to work. It could work very well. However, that could potentially change based on the environmental conditions which are causing the client stations or the stations not to hear each other.
Yeah, that's absolutely true. And was there anything else? Maybe you I know you were following the chat. And so
I did
forth.
see
Anything
the chat. A couple of things. I mean, I did mention with hidden node ERP protection mechanisms. I mean, I love to say, you know, B is dead, B is gone, but it's not. Unfortunately, from an educational perspective, WEP is dead. TKIP should be dead. B is dead, but it's still there. I mean, it's easy to say, well, I need to upgrade the barcode scanners, boss. And you have 3,000 barcode scanners or handhelds at $3,000 a piece. It's easier said than done. So from an educational perspective, yes, it's dead, but it's still there for legacy gear.
Yeah. Yeah. And that's important to keep in mind. And it varies by industry, right? So industries that bought into some of these technologies early on had huge capital investments in it. And a lot of them still have all those devices. And guess what? No moving parts, right? I've always said this for years. The reason my Commodore 64 still works, no moving parts. And when you have computing technology with no moving parts, it seems to last forever. And that means we keep it. Well, Robert, really appreciate you being on with us here today and all that you've done. You also taught the CWNA 108 beta class before the conference. That went really well. Some great positive feedback from that. So for all you do and all the many years you've worked with CWNP, no comment about the color of your beard intended there. Thank you very much for being with us today.
All right. Thanks, Tom. We'll see you soon. I appreciate it.
All right. Take care.
All right.